Hello everybody, today we're looking at section 410 and we want to know how do you write an equation of a quadratic if you're given specific points on the graph. So if we're given coordinates on a graph, how can we come up with the equation of the line? Now the process depends on what points we're given. Okay, so there's three different possibilities here, and the first one, we'll go through an example of each. The first one is, what if we're given the vertex and some other point? If we're given the vertex and some other point, we can come up with the equation of the line. And if that's the situation, then we're going to use vertex form. Okay, we all know what vertex form is written right here. Okay, so for an example, let's say the vertex is at 4, -5, and it passes through 2, -1. Okay, so we have a parabola with a vertex at 4, -5, and it also goes through this point. We only need these 2 points to come up with the equation. So here's my 3 steps. First, I plug in the vertex. Okay, so this is my, remember, HK is the vertex. So 4 goes in for the H, -5 for the K. Okay, so now remember that the H is always kind of like an opposite there. So if this is +4, when we plug it in here, it's x minus 4. The -5 makes this plus k a -5 there. Okay, step 2, find the A, the stretch factor, using the other point. And we're going to do that by plugging 2, -1 in for x and y in the equation. Okay, so y is -1. And all that we have left to do here is solve here for A. Okay, so let's see what we get here. Now parentheses first, so we have to subtract first. I get -2 squared. When I square -2, I get 4. So this is 4, and this is multiplication here. So it's A times 4 minus 5. So we have to add 5 to both sides before we solve for A here. So that's going to be 4 equals 4A divided by 4, and I get A equals 1. So now I can write my equation. A is 1, H is 4, K is -5, so that's my equation. Now because A is 1, I don't technically have to write that 1 there, but I just want to do it for demonstration purposes for this problem. So that's the process. If we know the vertex and another point, we can substitute the vertex in for H and K, the other point in for X and Y, and solve for A, and we can write our equation. Okay, so that's vertex and a point. Now what if we are given the x-intercepts and a point? It's pretty similar. If we're given the x-intercepts, we're going to use intercept form. Okay, so let's do an example. Let's say the x-intercepts are -1, 0, and 4, 0. And then it passes through 3, 2. Let's see what we get. So now we're going to plug P and Q are my intercepts. So we'll plug in the intercepts. Now remember, again, it's a minus here. So they're kind of like opposites. So +1 and -4. Okay, now we're going to use the other point, 3, 2, to find the A value. Okay, so again, we're going to plug 3 in for the X's, 2 in for the Y. So now, parentheses first, 3 plus 1 is 4, 3 minus 4 is -1. Okay, so I'm going to get 2, and this is all multiplication, so it's -4 times A, divided by -4, off the page. And that's going to give me an A value of -1/2 there. Okay, so I'll write the equation over here. -1/2, x plus 1, x minus 4. So that would be the equation of that one. Okay, so that's x-intercept and a point. So if I'm given the 2 x-intercepts and a point, use intercept form, substituting in your x-intercepts for P and Q, and then substituting in for x and y to solve for a. Okay, those are the kind of the two easier ones. The third possibility is, what if I'm given 3 random points on the parabola? Okay, this is where it gets a little bit more involved. We are going to use standard form in this case. Okay, so let's just say our parabola goes through -1, 0, 1, -2, and 2, -15. Okay, so now how do I come up with the equation? Well, it says create an equation for each point using standard form. Okay, so what we're going to do is we're going to substitute into standard form, ax squared plus bx plus c, these coordinates in for x and y, and come up with 3 equations and 3 unknowns. So let's start with this first point. 0 is y. Okay, and the 2 x's are -1. Second point gives me this equation. And then the third point, -15 for y. Okay, so that's the first part. We create an equation for each point using standard form. But now we're going to simplify this equation down so it looks a little better. So we're going to square. So -1 squared is 1, so I'm going to get 1a plus, actually it's going to be plus a -1b, or minus b, plus c equals 0. That's my first equation. That comes from the first one. Second one is 1 squared is 1, so it's going to be a plus b plus c equals -2. Third equation, 2 squared is 4, so it'll be 4a plus 2b plus c equals -15. So what we've come up with is a system of 3 equations and 3 unknowns based on substituting these coordinates in for the x and the y and simplifying. Okay, now we learned how to solve these 2 ways. One using elimination and the other using a calculator. Okay, so in this section you could use a calculator if you got one, and we'll go through an example of that in class with our calculators. But I'll solve this one using elimination. Okay, so I'm going to label these 3 equations, and I have to pick 2 equations and eliminate a variable. So most people would look at that and say, okay, I've got a minus and a plus here, so I can just take those 2, add them together to eliminate the b's. Again, there's a bunch of ways we could do it, probably easier ways, but let's see what I get here. 2a, the b's are gone. I get that. Okay, so I used equation 1 and 2, eliminated the b's. So thinking back on what I'm supposed to do next, I got to use the third equation of one of the others and eliminate the b's again. So let me rewrite the third equation here. And I'm probably going to take equation 1 and multiply it by 2, so I have opposites there. So this is going to be 2 times equation 1, 2a minus 2b plus 2c equals 0. 2 times 0. So I got 6a plus 3c equals -15. Now I have to take these 2 equations together and do some elimination there. So maybe I'm going to multiply this equation by -3. So let's see, that's going to give me a -6a, -6c equals 6. Okay, so this a's are gone. I got -3c equals -9. Divide by -3. Looks like c equals 3. Alright, so we've got the first variable. Now we substitute back in, probably into one of these 2 equations. Let's just use this one here. And we'll go and solve for a. 6a plus 3 times 3 equals negative 15. So I've got 6a minus 9, add 9, 6a equals negative 6. So a is negative 1 there. Okay? So now I've got a, I've got c, I need b. So let's work our way backwards here. Probably use equation 2 here. A plus b plus c. I'm all over the page. Apologize. So a is negative 1. Don't know b. C is 3. Let's see what we get. So negative 1 plus 3. So I got b plus 2 equals negative 2. Subtract 2. B equals negative 4. Okay, so I've got my equation. Now I work my way back and I substitute that into standard form here. And I'll have my equation. Y equals a is negative 1 x squared minus 4x plus 3. Oops. So that would be my equation because that's my a, that's my b, and that's my c. So I've got an equation. Okay. Again, if we have a graphing calculator, we can do inverse matrices to solve that system of equations. And I can show you how to do that in class if you have a graphing calculator. And that'll be the end of section 4.10.